Most people think cybersecurity starts when an alert appears. They are wrong. Cybersecurity starts long before than that. It starts with visibility. Because if your systems can't see what's happening, you don't get an alert. You don't get a warning. Watch this. Right now I'm sitting on Kali Linux, and in few seconds I'm going to interact with another machine on this network. Nothing crazy, just a simple scan. But what matters isn't the scan. What matters is whether somebody notices. Because in a real company, the difference determines whether an attacker gets caught in 5 minutes or stays hidden for 6 months. Run the scan. Watch the dashboard. The alert appears. I didn't touch Wazuh. I didn't refresh anything. I didn't manually check logs. The Ubuntu agent saw the activity and sent the telemetry to the manager. The SIEM processed it. And now an analyst knows something happened. That is visibility, not a definition, not a certification answer. Visibility is the reason we are even having a conversation about this event. Without it, the scan never existed. Today we are continuing the journey. We are focusing on two pillars that quietly determine whether a SOC succeeds or fails: interfaces and visibility. Because there is something beginners don't realize, finding threats is only the halfway job, and the other half is getting the right people to act on them. And that's where things get messy. Let me show you a nightmare scenario. It's 2:30 in the morning. Your SIEM generates an alert. A server inside your environment is communicating with an IP address nobody recognizes. The traffic volume is increasing. Something feels wrong. The analyst starts investigating. Checks logs, checks destination, checks recent activity. And after 10 minutes, they are convinced something is compromised. Now what? Most students imagine the analyst pushes a button that fixes everything. That's not how real organizations work. The SOC analyst usually doesn't own the server. They don't manage the network. They don't control user devices. They don't even decide whether systems taken offline or not. So despite being correctly identifying the threat, they still need help. And this is where many organizations fail. Because they missed the alert. Because nobody knew who should act on it. Maybe the endpoint team owns the devices. Maybe the infrastructure owns the server. Maybe the issue came from a deployment team. Maybe a firewall changes are needed. Now imagine none of these teams have clear responsibilities. Everyone assumes somebody else is handling it. Meanwhile, the attacker keeps moving. That's why interfaces exist. Not for paperwork. Not for organizational chats. Interfaces exist because incidents move faster than meetings. And if your team don't know how to work together before an attack, they definitely won't figure it out during one. An interface is simply a connection between SOC and another team. But those connections have rules, expectations, timelines, responsibilities. Think about helpdesk. Their goal is usually speed, close tickets, resolve user problems, and move on. The SOC has completely different goal. Accuracy, evidence, risk reduction. Sometimes those goals collide. Helpdesk wants the machine returned to the user. The SOC wants the machine to be isolated. Both think they are right, and both can justify the decision. That's why mature organizations create SLAs, service level agreements, a documented answer to a simple question. If SOC finds something dangerous, who responds? How quickly? And who makes the final decision? During an active incident, nobody wants to debate ownership. They want a plan. And that's what interfaces are really. Not communication or operational trust. A predefined way of organization to move when something bad happens. Now, before we jump back into the lab, there is something that confuses a lot of people in the first trend of cybersecurity. You will hear analysts say things like pull the forensics evidence or check the telemetry. And people use those terms like they are interchangeable, but they are not. Let me show you the difference. Imagine somebody breaks into your house, the police arrive, they collect fingerprints, photographs, DNA samples, security camera footage. Everything is documented carefully, nothing gets altered. That's forensics. Now, compare that to telemetry. Telemetry is the live stream. Everything is happening right now. Every login, every process, every file change, every network connection, every authentication request. Telemetry does not wait for a crime, it records everything. Think of it like a city full of CCTV cameras. Most of the footage is boring. Cars driving, people walking, nothing unusual. But when something bad happens, investigators go back and replay the footage. That's telemetry. And in SOC, telemetry is life. Because without telemetry, you don't know what happened. You only know something went wrong. Here is the scary part. Attackers don't need your entire network to be invincible. They only need one blind spot, one server nobody monitors, one account that nobody is connected to, one endpoint logging is disabled, one forgotten mission under someone's desk. That's it. Because visibility isn't measured by what you can see, it's measured by what you cannot. And some of the biggest breaches in history weren't caused by sophisticated malware. They happened because nobody noticed activity that should have been visible. Not because the logs didn't exist, because nobody was collecting them or nobody was looking. When analysts talk about visibility, they are speaking one question. They are really asking one question. If something bad happens right now, where would we see it? And if the answer is we wouldn't, you have a problem. So, where does visibility actually come from? Not one place, not multiple layers. Let's start at the bottom. Network visibility. This is traffic moving between machines. Who is talking to who, which port is being used, how much data is moving, and where it is going. If a server suddenly starts communicating with unfamiliar country at 3 in the morning, network visibility helps us see it. There is endpoint visibility. That is where Wazuh lives in our lab. Processes, files, users, services, everything happening directly on a machine. Then we move into application. Web servers, databases, authentication systems, the software people use every day. And finally, cloud visibility. AWS, Azure, Google Cloud. Because modern attackers don't care whether your server lives in a rack, downstairs, or a data center on other side of the world. If it's part of your environment, the SOC needs visibility into it. And here is the important part. Attackers only need one layer to be missing. I am back on Kali and I'm going to run a simple port scan against the Ubuntu machine. Nothing advanced, no malware, no exploitation. Just a simple scan. The first thing an attacker usually does after landing somewhere, they want answers. What systems are alive? What services are running? What can I talk to? Let's run it. Now watch the dashboard, not the terminal. The terminal only tells us what an attacker is doing. The dashboard tells what the defender sees. And there it is. An alert generated. Now pause for a second. This is where beginners usually make a mistake. They see an alert and immediately assume attack detected. No, an alert is not evidence. An alert is a question. Something happened. Now we investigate. That's the job. Not clicking buttons, not thinking. Looking at what actually we have. Source IP, destination IP, timestamp, rule triggered, host involved, context. That's what analysts work with. Now comes the part nobody talks about in cybersecurity courses. Documentation. Because finding a threat isn't a finish line. It's the beginning. Let's create an incident ticket. Ticket ID, time detected, source, affected asset, observed behavior, recommended action. Notice something interesting. This ticket isn't written for me. It's written for everyone else. IT operations, help desk, security engineering, management. The SOC is translating technical evidence into decisions. And that's why interfaces matter. Without them, the alerts stay inside the SOC. With them, the organization moves on one alert, multiple teams, one coordinated response. That's how incidents are actually handled. Not by one person, by an entire ecosystem. So let's put everything together. Visibility tells us what's happening. Interfaces determine what happens next. Visibility without interfaces means we have the problem, but can't act. Interfaces visibility means we have teams ready to respond, but nothing to respond. This is what SOC actually looks like.